Hello everyone, welcome back to our data mining course. So in our previous lecture we learned about different types of data attributes and how the data mining system works along with different applications and issues that we deal with the data mining. So today we are going to learn one of the most important topics in data mining, which is nothing but data pre-processing. So in data mining we don't directly analyze the raw data as I said earlier. So we first clean, then we organize and we prepare it. So this preparation process is called data mining. So in today's lecture we will understand why pre-processing is essential and the major pre-processing tasks and the techniques used to improve data quality. So now let's understand why pre-processing is needed. Suppose you are a doctor diagnosing a patient. Would you make a diagnosis using incorrect or incorrect medical records? Of course not. That won't happen at all. So similarly, data mining algorithms can only produce accurate results if the input data is good quality. Remember. So an algorithm will not be able to give an accurate result until unless whatever the input data which you give which has a good quality. So this is applicable for most of the algorithms. So this follows a very famous principle, garbage in, garbage out. If poor quality data is given as input, then the output will also be poor. Remember all the time. So your input should be of good quality. So when I say about this quality, now we should be following some characteristics to make sure that I have a quality data. So that's what about all this. So the first one is accuracy. So accuracy means the data should be correct. For example, if a student's age is entered as 250 years, is that accurate? Obviously not. No one can live till 250 years. So this is not an accurate one. Next, second one, completeness. Completeness means no important information should be missing. I should not have any incomplete data. So for example, imagine a hospital database where the patient's blood group is missing. So if a patient doesn't have any blood group, then whether the proper diagnosis or some decisions will be able to make by the doctors, of course not, will be become difficult. So this is what completeness. So you should have a complete data. For example, if I ask you to fill the student details, if some of them, if they are not entering the mobile number, of course you will not be able to send any messages over the group. So it's an incomplete one. So third one is about consistency. So consistency means the same information should appear everywhere. So whenever, at any time, irrespective of any time or any place or anything, you should have the consistent data should appear everywhere. Suppose one department stores a customer name as Rahul and another store it has R Rahul. So are they the same person? So in one customer, in one place it is just a name, in another place it is entered along with the initial. So possibly it could be the same person, right? So but the inconsistency creates a confusion. Sometimes it happens. Now, so some people they have in bank card their last name in the beginning. Some people they will be having their last name at the end, but the same person, right? So this is what the consistency. So next it's about timelines. So data should be updated regularly, right? So if I want the student details till 7th semester to make them appear for the placement, then I should be having till 7th sem record, right? So just by having the second or third sem record, I cannot say the person whether they have the criteria, they met the criteria, right? So that's what basically your data should be updated regularly. So next one is about believability. So this refers to how trustworthy your data. So would you trust the information from an official government database more than an unknown website? So of course we rely on the government. So it's a reliable one. It's from the government, right? So that's what basically trustworthy. So next it's about interpretability. So finally the data should be easy to understand, whether the end users are able to understand, stakeholders are able to interpret what your representation or your data is about, right? So imagine opening a file filled with codes that nobody can interpret. Obviously, right? We cannot say all the people, have the ability to understand the coding. That won't happen at all, right? So even if the data is correct, it won't be useful. So these are the basic characteristics where you can say your data has a good quality, right? So if the data quality is poor, then what should we do? Then obviously we have to do the data pre-processing. If I have the quality data, I don't have to go for the data pre-processing at all. But we cannot say 100% that my data is having a good quality. So we have to apply data pre-processing to make sure that my data quality is very good. So moving on to the next slide, we have major task in data pre-processing. So data processing is basically, it's not just one activity. It consists of several important tasks. So let's understand them one by one. So the first task is data cleaning, right? So what is data cleaning? Let's see. So imagine your room is messy. Before stealing, you clean and you organize it. Similarly, data cleaning removes the missing values. For example, someone did not enter the data, example mobile number in the student information. So that could be taken as a missing values. So second one is about incorrect entries. So what is incorrect entry? So I'm asking you to enter your age, but you have entered your mobile number. So that's an incorrect one. So third one is about duplicate records. So duplicate records, if you take same record is appearing in many places and inconsistencies, right? So these are the ways we have to remove the data cleaning. So these are the basic things that appear in the data. So we have to do the data cleaning. So second one is about data integration. Suppose a university stores its student information in one database and examination results in another. If we want to complete student information, these databases must be combined. So this process is called data integration. I'm going to integrate my data of students that present in different databases to make sure that I have some common information of students. So this is the second one, right? So that could be from multiple databases or multiple cubes or files. Then third one is about data reduction, right? So large companies like Amazon and Google store petabytes of data. So analyzing every record is time consuming. So data reduction reduces the size of data set while preserving useful information by applying many methodologies like dimensional reduction, numerosity reduction, data compression. So I will be explaining more on the problems about the data reduction in the upcoming classes. Then fourth one is about data transformation. So sometimes data needs to be converted into some other suitable format to make it simple or easier to understand. For example, if one system stores salary in rupees and another stores it in dollars, then they must be standardized before analysis, right? So this is what basically data transformation. And third and fifth one we have data discretization. So continuous values are sometimes converted into categories. So for example, instead of storing exact ages, we can classify them as child, adult, senior citizen. So this simplifies analysis. So this is about data discretization. So these are the major tasks which we have in data pre-processing. So now let's discuss the first and most important pre-processing task, data cleaning. So real world data is rarely perfect. It often contains mistakes. So these mistakes can lead to incorrect business decisions. So let's look into some common problems. What makes this process it's a tedious one, and why we have to go for the data cleaning. So the first one is about incomplete data. So as I said earlier, this could be where your attribute values are missing, or your you are making incomplete fields, or not entering the data at all. So example, in occupation you are not entering your data at all, right? So this could be taken as an example. So second one, it's about noisy data. So noisy data contains incorrect values. So what it is? So for example, suppose an employee salary is entered as minus 50,000 or minus 10. So can salary be negative? Of course, obviously it's not. So this is an error. So whenever you have the incorrect values, then that belongs to noisy data. Then third one is about inconsistent data. For example, imagine a student record shows age equal to 42 and birthday, they have mentioned 3/7/2010, and sometimes this date of birth, that could be indicated, that could be either correct or not correct. So both, cannot be true, right? If it is true, then you can agree, right? You have mentioned your age is 42, but the birthday date, it's something totally different. So this is basically inconsistent data, and grades also you can take. And next about duplicate records. For example, as I told earlier, some people, they would have kept their last name in the first place and last name in the respective place, but it belongs to the same person, but it appears many times. So these are all basically duplicate records. So again, so we are going to see in detail about incomplete data. So what are the basic reason that we have for this incomplete data? So what is missing data, right? So maybe the user skipped a question while filling out a form, so that could be the reason, right? Maybe the machine collecting the data failed, that could be another reason. Maybe the old records were lost, right? So, or perhaps the information was not considered important when the data was entered, right? So these are the basic reasons why we have this missing data. So suppose you are registering on a commercial e-commerce website, so you provide your name and email but skip the income field. So now the database contains missing information. So how to handle this missing data? So there are several techniques we have. So first, you ignore the tuple or ignore the record. So if only a few records have missing values, then you can simply be removed. However, if many records are incomplete, deleting them would be waste valuable information. So next one, it's about manual filing. So we can manually fill in missing values, but imagine updating 1 million customer records. Obviously it's not practical, and it will take more time. And next one, another option, we have global constant. So we may replace missing values with a word like unknown or nil or not available. So all the missing values will be replaced with a global constant, right? And also we can take mean value or class mean. So some prediction methods also we can take, like for example, modern systems use AI techniques such as decision trees and Bayesian methods to predict the most likely missing value. So these are the different ways how to handle the missing data. So next we are going to see about noisy data, right? So what is noisy data? Basically it's an incorrect data. So noisy refers to random errors or incorrect values in a data set. So for example, imagine a patient body's temperature is recorded as 250 degrees Celsius. So is that possible? Of course not, right? That won't happen. So noisy can occur due to faulty sensors or typical mistakes, through some transmission errors or some other errors commonly occur. For example, maybe software cut. So how do we remove noisy data? So one method is binning. So here we sort the data into groups called bins and replace value using the mean, median or boundary values of each bin. So another technique is about regression, where we fit a line or curve the data to smooth out random variation. So these are the different ways how we can handle the noisy data. So I'll be explaining more on the problems, or maybe I can show how this gaming, smoothing by mean, smoothing by being model by being model. Simple example I can explain in the upcoming lectures. So next it's about data integration. So data integration, basically how do we integrate the data from multiple sources to make the common one, right? So as I said earlier, we are going to integrate the data, but that belongs to the same data. So for example, a university may have separate databases for admission, examinations, library records and hostel management. So if we want complete information about a student, we need to combine these databases. So this process is called basically data integration. But this is not always easy, because one database may use student ID while another uses roll number. So although they refer to the same person, the attribute names are different. So it's a different, tedious process, right? So this is called basically entity identification problem. So another issue is data value conflicts. For example, one database may store weight in kilograms while another store it in pounds. So before integration, both values must be converted into common units. So these are the basic difficult things that arise during data integration. So next, it's about data reduction strategies. So modern organizations generate enormous amount of data. Google process billions of searches every day, and Amazon records millions of purchases. So analyzing every record takes time and computing power. That's why we perform data reduction. The goal is to reduce the size of the data while preserving the useful information. So there are several techniques are available. So I will be explaining more on the techniques in the upcoming lectures, but today I am going to briefly say about the techniques. Dimensionality reduction. Here we have wavelet transforms, PCA, principal component analysis, feature subset selection, feature creation. Second one is about numerosity reduction, where we have regression, log linear models, histograms, clustering, grouping the data based on the similarity, then sampling, then data aggregation, then data compression, basically used to reduce the sizes but not compromising the quality of data. So these are the basic data reduction strategies which we have, right? So next, it's about parametric data reduction, regression and log linear models. These are all another methods how to reduce the data by applying linear regression to fit a straight line or multiple regression model. Then log linear models basically approximates discrete multidimensionality probability distributions. So I'll be explaining this regression analysis problems. It's a another big concept. We have problems also. I will be explaining more on the regression analysis in the upcoming lectures. So, and again clustering, basically grouping based on the similarity. So again this is a huge concept. So I'll be explaining elaborately along with the types. Then sampling, basically sampling, you have huge collection of data, but I don't want to take all the data. Instead of that, I am going to take a sample from the original data to represent the whole data set, and I will be applying my mining algorithm to run in complexity that is potentially sublinear to the size of the data. So sampling basically that is used to avoid the time complexity. So I will be taking a small portion of the data, I will apply my algorithms and I will find out the result from that. So there are different types of sampling algorithms we have, like simple random sampling without replacement, sampling with a replacement, stratified sampling, etc., etc. So here we have simple example given. So without replacement, with replacement. So you can change, you cannot change. So these are the two ways. So again, this is how cluster or stratified sampling. So you have the raw data and you are going to form the group based on the similarity. So here we have the 3 clusters with 3 different types of data. And data group aggregation, again you have aggregated data which is representing an individual entity of interest, right? Next, again data compression, without changing the quality of my data, also reducing the size of the data. That is the aim of data compression, right? So you have the original data, then you have the original data approximated. Basically compressed data will now have the lossless data, and sometimes if it is lossy, then your original data is approximated. Then data transformation, as I said earlier, we are going to do the transformation from one format into another format for your easy understanding. So this could be happen with the help of smoothing method, aggregation methods, normalization, discretization, etc., etc. So these are the different methods you have to apply during the deprocessing. So as I said earlier, you have many methods: data cleaning, data integration, data transformation, handling the missing values, data reduction, clustering, sampling, etc. So all these ensures that your data is of good quality. So no matter how advanced the algorithm is, poor quality input will always produce poor quality output. So that is the main reason we move behind the data preprocessing. So if you have in the next lecture I will be explaining more on the methods how this data processing that happens. Okay, thank you.